Alright, we're on the... Okay. Good morning, actually, or whatever time it is in your place. My name is Bernardus, and today we'll be talking about process and threads. Not process and threads, actually, but just threads, alright? Because you'll get it later. So, as usual, this is the issue you can visit so that you can see what did I do throughout the week. And actually, I copy pasted the entire thing twice, so usually during the third day I pasted everything so that it's like the conclusion, right? But for the third day I copied the entire thing and then I forget to create the CLI. I don't know if I promised it or not, but I forget, so I copy pasted the whole thing again with the readme. So yeah, you can see penguin search. Okay, so without further ado, let's get started. Process and threads in Java. So the first day, we'll be mainly talking about the traditional thread. So it's very similar to C thread, but yeah, it's very similar, but with the object-oriented nature of Java. That's basically it. Yes, I made this entire thing while being sleep deprived. I'm still sleep deprived, by the way, so let's get this finished quickly because I got event to attend to after this. So, process doesn't exist in Java. Yes, threads probably said, where is his brother? So, in Java we technically can do what fork do, but JVM, in Java, JVM is just a normal ring tree process. And inside the JVM, your code is just being run by JVM with a bunch of workers or threads inside. So, if I'm not mistaken, I said Java is a nested process inside a process. It's wrong. Your code is interpreted inside the JVM as one or more threads. I don't know where, but I was wrong. So, if you find any technical mistake I did throughout my self-learning journey, public learning, feel free to call me out, okay? So, because I want to grow as well. So, thread and runnable. This is thread. So in C, we pass a pointer function, correct? Which means we pass the task to the thread. In Java, the logic is more or less quite the same. Runnable is basically that pointer function. You create an algorithm or a set of tasks inside it, and then you will pass it to the thread, because remember, Java is object-oriented programming, not functional programming. So basically, this example right here, let's pass it to IntelliJ. Oh, no. Okay, so probably I'll skip this for now. I'm still in my penguin search code. This is the MD. Wait. Recent projects, my job. Wait. Recent project, Java CLI 25. This one. Okay, so I'm gonna skip the IntelliJ introduction for now. But what this code basically does, okay, grammar. So you create an algorithm or some task to be finished with the type of runnable. Runnable is basically task you do that doesn't return anything. So it doesn't return null, it doesn't return anything, basically just task. Get the current task name and then print it, and then we have the thread to find the worker and then start it. Yes, that's basically it. Alright, let's copy paste this to here and then run it. IntelliJ build is quite slow in my personal computer because my computer is not that new. It's quite old actually, 5 years if I'm not mistaken. Okay, the build, yes, hello from thread 0, that's basically it. And then we got to the data race, what we learned in C. Remember mutex? In Java, mutex is located in the mark word of every object. But merely creating a pthread mutex lock doesn't stop a race. That's where the synchronize keyword comes in. Synchronize makes sure whatever is done here will pause the execution of other threads. So let's see here. We have a local counter added to 1 million, yes, added to 1 million, and then we update that one. We update the we update the data. Now the synchronized means that whatever code, when you reach this line 34, it will pause the execution of the threads, basically locking everything to prevent data race. And as you can see, the result here speaks for themselves. It doesn't trigger a data race. Synchronized needs the reference to the object. When the thread starts executing other method, it doesn't stop other threads yet. Instead, it waits for which thread hits the line of synchronized this first. If you want to immediately suspend every thread other than the first thread to hit this method, just put the synchronized method in name. So basically, it's not when you reach the synchronize this inside the code. Instead, when this method starts being executed, every other thread will be paused immediately. I don't know if this is faster or not, but I'm sure this is faster, right? Main.java. Oh. Yes, as you can see, it doesn't. Why is it 2 million? Why is it 2 million? Alright. Okay. So it does, as you can see, it just freezes on the counter value 1. So yeah, at least the end result is quite true, right? At least the end result is true. Okay, let's just keep going. So reentrancy, I will not lock myself. Yes, let's get back to C time. In C, mutex is a simple lock or unlocked. When thread L locks the mutex and somehow inside that same function it tries to lock the mutex, it will hang forever because thread A is waiting for the instruction to finish, but the instruction is also waiting because it is used by thread A. So in Java, you don't have to store locked or not. You have the owner, and you don't just store locked or not. You have the owner and the counter. If inside the same object you call synchronized methods, instead of locking, it will increment the counter to 2 synchronized with the owner of this method. So no hanging until the end of time. You need to work. Okay. Sorry. Just pass this one. So this code, we create a task. Inside this task, we call the method outer. Outer calls the other synchronized methods inner, which should basically means they should lock each other if this is C, but we're in Java, so it shouldn't be like that. Yes. Hello from thread 0, enter outer, hello from thread 1, inside inner, this is inner 0, and then we're existing outer. Yes, it doesn't hang forever and trigger. It doesn't hang forever, basically, yes. Okay, so now that we've been this far in thread, so we need to understand thread lifetime in Java. It is quite different from the C or basically OS lifetime, but it is mapping 1-to-1. One Java thread equals one OS thread, except something that we'll learn later. But for now, just understand that a thread is a thread, a Java thread is an operating system thread. So we know that thread or an execution has 5 phases. New, which is when they are still being created, ready when they are ready to run, running when they are running, waiting when they are sleeping, and terminated when they are finished. In Java, it's different. We have 6. New, when exists in the heap, but start hasn't been called yet, no as threads exist. Runnable, the thread is executing the JVM or is it ready? Basically, combination of ready and running in one. Block, it is waiting for a mutex. The thread is waiting to enter a synchronous block, waiting indefinitely for another thread to perform a specific action, timed waiting for sleeping, and terminated when finished. No running, running and ready are merged into Runnable. Java is modular, remember? It must work with every single operating system. It leaves the interpretation of running and ready to the user's operating system, whether Mac OS, Linux, GNU Linux apparently, or Windows. It's up to the operating system. So we create a task again right here, and then we start, and then we join. We need to try because how do you wake up the main thread? Throws an interrupted exception. So let's say thread first worker have something to do that needs the main thread to wake up immediately. How do they do that? They slap the main thread with interrupted exception. So this is why we do this, right? So we join basically means the main thread will wait for this specific thread to finish, and then yeah, that's basically it. Finish running thread. Runnable because getStat is called when, you guessed it, the thread running. So interruption, no guillotine. In C, you can essentially purge thread in the middle of their turn. In the middle of their turn or run, but as you can guess, unsafe. But in Java, thread.stop was deprecated and now we use thread.interrupt. But don't get your hopes up. It's just a toggle for boolean that the thread will read, and if it is set to true, then it will throw interrupted exception, which must be handled using catch, what I said earlier. So, okay, so as you can see here, we pass a runnable to a thread, right? But this time, we combine them into a single lambda, and this lambda will get converted into a runnable. If I'm not mistaken again, alright? So, thread worker, and immediately creates a runnable inside it. So we use while, so to check indefinitely when the current thread is interrupted. If it is not interrupted, do work. But when it is interrupted, we'll throw the catch and do this. Okay, so as you can see, sleep right here, right? But if it is interrupted, we'll do catch interrupted exception. I was interrupted while sleeping, and then we preserve the interrupt status. So when you catch the interrupted exception, the boolean switch back to false. And when other threads see that, okay, this thread is still alive, they can do whatever so they can do unvalid operation because this thread is actually dead, but they see that the boolean is false, so this thread is still alive, right? So that's why we preserve the interrupt status. We interrupt it again to break it, exit the loop. So worker thread safely shut down, we sleep and then interrupt. Let's see it in IntelliJ IDEA in action. Working hard, working hard, working hard, working hard. I was interrupted. So what's basically happening is that this runs for 5 seconds, it starts, then sleep for 5 seconds, and then immediately interrupt the worker. After interrupting the worker, it will catch interruption, which cuts the interruption exception. Will catch the interrupted exception, and then yeah, that's basically it. So yeah, I wrote this, I finished this writing around 11:07. So yeah, I was really sleep deprivated actually. So now we're entering the easy way for threads, so we don't need to stress at 11 p.m. So I'm on 6 hours of sleep right now, so it's better than my past, okay? So the first one is ExecutorService, the benevolent manager. So thread is a worker, and in C and Java, you need to be the CEO, manager, and HRD, and tiring and prone to errors, because we're human, remember? So Java has an object called ExecutorService that acts like a manager. You drop the task, and it delegates tasks between workers. So instead of a thread or worker doing a task and then get killed, the thread will instead work on other tasks. Because remember, context switching between threads is expensive. Killing and creating a new one is also expensive. Even though it is not as expensive as creating a new process, it is still expensive nonetheless. So that's why a thread will do many tasks. As you can see, yes, we submit a task 10 times, and it's quite fast because we created 4 workers for this. Why the try? It means wake me, the main thread, when a thread called main thread.interrupt, which, as we learned, how do you wake up a thread immediately? You bonk him with an interrupted exception. So try executor await termination. So if I'm not mistaken, await termination returns. Wait, let me fetch the documentation. Okay. Returns true if the executor terminated and false if the timeout allows before termination. So let me read that again. True if this executor is terminated. Oh, okay. So if the executor is terminated, we shut him down. Oh, sorry. If the executor hasn't been terminated yet, we immediately shut him down. But if he's terminated, well, just let him be. He's already terminated. But if the main thread is suddenly woken up, we immediately shut down this, and then we interrupt our current main thread. Yes, that's basically it. So other than executor signaling all threads are closed or 1 minute has passed, a thread inside worker can call interrupt on the main thread. So that's why the try catch. Basically, a way to escape the thread is to interrupt. So I drank chocolate milk, yes, and I just got more sleepy for my own good. Let's go. So in process and threads, we learned about context switching between threads is expensive. The same with Java thread. So we have what's called atomic variable. Instead of switching thread state to blocked, we do a special CPU's instruction. Compare and swap or CAS. Close error support. Oh my. It's basically an optimistic approach. It tries to switch first and handle error later. So go to this variable and increment the value by 1 if the value is still 10. If it's changed, redo it until successful. Because checking is far cheaper than switching thread. That's why atomic variable. So let's say we have a fixed thread pool. We do this 10 times, and then the 5 threads will repeatedly fight each other for incrementing the atomic integer. It is still far cheaper than switching the CPU state to block thread switching, but remember, if you have 99 threads, only 1 thread wins and the other 9 competes again. So don't use this for everything, only uses it when the task is small and the cost of retry is far smaller than nanoseconds of CPU's blocking. But remember that every non-primitive variable in Java is a reference, and a string is immutable, and it just changes the reference to the string pool. That's why there is atomic reference, so you can decide which one. Atomic reference. Yes, this basically just holds the reference, and then yeah, redo the entire thing. Let's copy paste this to the JVM. Yep, that's basically it. Wait, what? wait, unchecked call to atomic reference as a member of row type atomic reference new, where v is a type variable. V extends object declared in class atomic reference. I don't know what happened, but I'll just research it for later, alright? So now, handling data is quite nice using array, but we can do better. There's concurrent collections. One of them is concurrent hash map. So in Java there are no threads safe, but you can bootstrap your way if you want to use array list in a multi-threaded environment, but most of the jobs can be tackled with concurrent hash map. This is very complicated, but think of concurrent hash map as a page table. You still remember them, right? So let's say a hash map of books is accessed by 4 threads at the same time. If thread A accesses book 1, which is located on bucket 1, only that bucket is locked, so the other bucket can still work, something like that. Concurrent hash map. So why put if absent? If put is a normal operation that could lead to zombie overriding between threads, whereas put, if absent, uses the compare and swap, which is make sure that you're safe. So put if absent, basically, yeah, as I said, use the compare and swap method of the CPU. Start this one, yep, this is the result, as you can see. And then we have countdown latch. ExecutorService is nice, it makes your life a bit easier, but you sometimes still need manual thread. So this is where countdown latch comes in. So let's say you have a use case that you can use executor and you need a way to manage workers efficiently instead of blind.join. This is where countdown.latch comes in. An atomic counter that makes sure your main thread can run immediately after prepping thread is finished. All the prepping thread is finished. So we declare the countdown latch. We start the thread immediately, and then we await the latch. And if the latch goes to 0, it immediately starts the program main thread again. Quite simple, actually. Why did I build? Starting her up. Nice. Go to the terminal first, and then we are entering day 3. Modern way of threads. Yesterday we talked about the easy way, but today we're doing easy and modern way of threads. And yes, I've slept, though it's not enough. Again, this time I didn't sleep enough. So feature and callable. Can I order a burger? Where's the burger, man? Okay, feature and callable. Can I order a burger? Do you understand a thing in JavaScript? This is similar to that, but for threads. This is JavaScript, alright? Not Java. Let me fix that. JavaScript, yes. This is similar to that, but for threads. You declare what you want from a thread and we'll give it to you when it's ready. Otherwise, wait. We have a normal task, and then we have a callable string. Callable basically can return. Wait. Okay, so Callable is runnable version that can return something. Feature is basically the result of an executor submit of a thread returning something. So as you can see, we can do it in one go instead of creating a new disk. But you can also create the callable first and then have the future second receipt runs that callable. So let's copy paste this to IntelliJ. Doing other things while doing it. Okay, so that's basically it. And then wait, notify, and condition. Notify me when you need help. I didn't know why I put the boxing lows. I don't even know myself, but remember that CPU is a hyperactive child, as we talk about in system calls. Yep, so it wants to use every nanosecond it has to do something. So this is where wait or notify comes in. Notify is the old way. Before condition was introduced, this is how do we say let me sleep, and when you have task from me, call me. So instead of a waiter waiting at the table for the customer to stop eating, finish eating, they go to the kitchen and they go to do other tasks. And when the customer call them, they will return. But this has one massive flaw. Notify, the method to do this, notify wakes up one random thread. Meanwhile, notify all wakes everyone up. So it's either a lose-lose situation. Yep, buffer produce, buffer consume. Basically call this synchronized. This is basically means you cannot produce if you reach the limit, and you cannot consume if you reach 0. So the problem, you have two methods as I said, notify, which notifies random people, or notify all, which literally wakes everyone up. Condition allows you to create rooms. For example, in a house there would be someone wanting to use the bathroom. When the bathroom is free, you only notify those who needs it, not the one who needs to use the kitchen or the bathroom. Bathroom. So this is basically, yeah, we have the class of room, and then we have two threads wanting to use each one. We only wakes those who needs to use the bathroom with the lock new condition. This is basically, lock is basically the Java object version of lock, and then is bathroom occupied, and since it is saved by the lock, we don't need atomic variable, and then we create the new condition right here. So we while the bathroom is occupied, we wait, and if the bathroom is not occupied, we immediately dips it and then use it for 500 milliseconds apparently, and then we signal all who want to use the bathroom to use it, and then we have to lock the unlock. Alright, so yeah, that's the same with kitchen. Yep, or one thread one. I don't know why it doesn't print the second thread, but that's basically pretty much it. So now we enter the last material for today. It is virtual threads, infinite penguin. Everything we learn exists because threads are very expensive, like real expensive. Not as expensive as a process as I said, but expensive still. In Java 21, we have what's called virtual threads. As an analogy, two servers at a restaurant wait for you to finish eating. Hell no, they disappear and serve other tables. So basically, virtual thread is a small Java object mounted to a few OS threads. So a virtual thread is basically a Java object with several OS threads. This is basically the earlier version, but the only difference is that ExecutorService now use virtual thread. Why did I open my WhatsApp? Alright, I'm gonna blur that one. So okay, so basically virtual threads is a small Java object and mounted to a few. So this line right here basically creates a new virtual thread per task, and since a virtual thread is just an object, it's cheap, so you just create that. Okay, so that's basically it. This is my readme for penguin search. Do penguin search right here. This is my code. You can see it right here. This is basically a mini grep. It looks through the folder you're entering for every files. It summons a virtual thread, so it's efficient. And instead of splitting, we use to search index of to search the text inside that one. So yeah, this is basically it for today. I need to edit this entire video due to that 1 millisecond. So I guess I want to end this video right now. I'm sorry if the quality is not as high as the previous week. I'll try to get back on my feet next week, and yeah, I guess that's it. I thank you all for watching, I guess, and I, Bernardos, thank you for watching this video and signing off.